Okay, good morning. Hope you guys are all staying safe and doing well. So it's our last meeting of the summer term, and so let me just cut this up to what we're going to do today and what you have to do for the rest of the term, I guess. Okay, so I should have all the assignments you submitted up to today or up to last week, I guess. Those you should have grades for all those if you check on Blackboard. So you should have grades for all the homeworks, chapters 1 through 8, and then so I put your grades for those, and there's solutions for all those. So I put up solutions for homework chapter 8. Yeah, those are right there, and then also I graded your midterm, the take-home midterm, so you should have grades for your midterm. And I believe I put my solutions for the midterm, so you can look at that. So those are my midterm solutions if you want to check those if you missed any points. But overall, you guys did very well on the midterm, so I was happy with the results there. Okay, and so all the homework, chapters 1 through 8 are graded with solutions, and then the midterm is graded with solutions. You should find your grades on Blackboard, and we only have a few more things that you have to do, including the final, which is just like another big homework basically. Alright, and then today, you know that a lot of you already turned it in, but by the end of today, by midnight, you're going to turn in homework chapter 9 and homework chapter 10 into the discussion forum for those. So those two assignments, make sure you get those in today if you haven't done that already. And then there's just the two final assignments, which you remember they're going to be due next Thursday, like it's said on the syllabus, Thursday, August 13th. Okay, and then that way I plan to get your grades in and submitted by Saturday, August 15th. So assuming everybody gets in all of their assignments on time, which I'm sure you guys will, and I will submit your grades on Saturday. I'll put your grades on Blackboard, and then I'll email you guys saying like, here you can go check your grades. So it might take a little while for them to be official in your Laverne portal or whatever, but you'll be able to see your grades on Saturday, assuming everybody submits all the work. Okay, so today we have another longer homework we have the oligopoly homework, which is going to be another like data analysis kind of thing, somewhat similar to some of the stuff we did in the elasticity homework, in the sense that we're using Excel and some data analysis. Then we have the final, so I have a practice final that I posted. I have a practice final solutions that we'll go over for review for the final. And then I'm going to give you guys your final. And then like it says in the syllabus, those are your last two assignments. Those are due on Thursday. Alright, so a little less time, but you should be able to do, I mean, you could probably do both of those in one day if you wanted to, but you have till Thursday. Okay, so any questions on any of the past homeworks, any grading things, anything before we start the last two things, which are what's on today for the oligopoly homework? We got to cover that, and we got to cover the final exam, and then that's it. Okay, so
Professor, do you think we'll be done early than 1:30?
I do. I think we'll be done a little bit. This will probably, we still have a couple. It's going to be at least 2 hours, but it won't be 4. So
Okay. Yeah. Okay, perfect. Thank you.
So this is based on what I think we have to cover for the rest of the course. I think this will be our shortest meeting, but I think we'll still be around 2 hours. But no more than 3. But I think it'll take about an hour to do both of the things, but we'll see. So okay. So before we start today's material, and so depending on how we're going, we can try to do everything in the first session and just not take a break, but we'll see. So before we do today's material, any questions on any of the previous assignments, or any just general questions before we finish up the last 2 big assignments?
No, we're good.
Okay. Well, yeah, all your grades are up. All the solutions are posted, so you guys have done pretty well, or very well in all of the assignments. I'm not too worried about the last 2 assignments, but okay. So basically, we have we're gonna go through a practice exam for the final, and then I'm gonna walk you through another little data analysis thing, and this will be the final homework. You got to use a little bit of Excel and get some data, but it'll be kind of fun to do some oligopoly analysis. So I guess it doesn't really. What do you want to do first? Do you want to do the final review and then get the final first, or do you want to do the oligopoly homework data analysis first? I think they'll both take like an hour, and it doesn't really matter which one we do first.
Well, let's do the oligopoly and then the review.
Alright, that's probably a better idea. Okay. Alright, that's what we'll do. Alright, so let's go to Blackboard. And I believe so once we finish this, this will be due right here in the oligopoly section by next Thursday. Right there. So everybody's done fine on submitting the homework assignments on discussion forums. So you guys have mastered that. So just get that one in by Thursday. Yeah. So I think I put the oligopoly homework material under the chapter 10 section. So if you go to chapter 10 on Blackboard. Alright, so the only thing we have to focus on here is the oligopoly homework. So let's go ahead and I'll open up I guess this is the assignment, the oligopoly homework. Alright, so this is, you're going to get a little bit of, I'm going to show you to get some data, and then you do just a little analysis and analyze some oligopoly. So let's go through the instructions here. And then I have an example that I've started, or I just need to update it, but I'll walk you through my example so you can use that and look at it if you need to see what I did, and I'll post my Excel file so you have my example. In case you have questions, and also this video will be available today or tomorrow. Alright, so here we go. So each student is going to be assigned, or you can pick 2 competing oligopolies to research, and so the suggested oligopolies, I have some here. I've thought of a few more since I've prepared this. So you want to pick 2 companies that have similar places in the market and kind of compete in an oligopoly structure like we're used to talking about. You can also pick I thought about you can also pick two, I guess, monopolistic competition firms as long as they are public and have it makes sense. So the ones I listed here. So this is always a good one: Amazon versus Alibaba, because those are the two biggest online retail and online store places, I'd say, in the pretty much in the world. Okay. Apple and Microsoft are always good. They're always relevant. They're the two biggest software and computer firms, so that's another good option. Even though Facebook's now probably, well, I mean, Twitter's grown a lot, so this is always a good one too. Facebook versus Twitter, and that whole social media oligopoly market. So those first three are good. And I think I think Netflix has grown a lot. I don't even know if I call this an oligopoly anymore, because Netflix is so much bigger than Roku. So if you wanted to do this one, I would say maybe like Netflix and Hulu. I don't know if is Hulu public? Is Hulu public? Do you even know if Hulu is a separate public company?
No idea.
Okay, well, we can look, but Netflix and Roku, I just think the Roku company is not as big as it used to be, but anyway, that's another option. And okay, Uber and Lyft is another good one. And so another one I thought of maybe is I don't know how interesting it is, but Coke and Pepsi that's more of a monopolistic competition. So I know that Coke and Pepsi are both public. That's another option. And so these are just suggestions. If you have anything else, you can present it to me, or if you have any other ideas, let me know. But anything else, any other big ones you guys can think of for oligopolies? Well, that's another option. But anyway, you can pick one of these, or if you have a better idea, you want to look at something else, you can let me know. But it's got to be two pretty big companies that have compete for similar products or services, and most of these are going to be oligopolies. I think the Coke Pepsi would be more of a monopolistic competition, but that would still work pretty well in this aspect. Alright, so anyway, there's 5 examples there. Coke and Pepsi is another one. I'll check right now if Hulu is public, and if you want to do Netflix and Hulu, that's another option. But anyway, and I have a separate example. I did Budweiser and Coors as an example, because those are the two biggest domestic beer companies. And so you can't choose those, but I have those as an example we can look through in a minute. Alright, so you're going to pick something. It doesn't matter if, hopefully everybody doesn't pick the same thing, but try to pick one of these 5 options that seems most interesting, or if you have a better idea, and you can think of something else, then let me know. Okay, so what you're going to do is get all the monthly data so all these are public companies, so we're going to look at the stock price data from Yahoo Finance. It's really easy to get, and I'll show you to do that. It's all public and free. Okay, and you're going to put the data in Excel, and you're going to get just the closing price, and you're going to look at it to compare these oligopolies. Okay, and then I'll show you how to make simple time plots so you can see what's happened. Depending on the industry, it might be affected by the current economy. I think some of the online retailers like Amazon are probably doing better, but some of the in-store things are probably doing worse. So it depends, but you can talk about that in your little discussion. Okay, and I'm going to show you 2 pretty much simple forecasting methods. So that we're going to learn for how to compare these. And so one is the moving average. And so I'll show you to do that and look at some errors. It's a pretty nice type to look at forecasting and do something different than a normal average. Okay, and then another one is just simple exponential smoothing, and these are, you might not be familiar with these two types or types of analysis, but you can put the formula in Excel. It's pretty easy, and I'll show you to do that. So we'll do those two things for your examples. Okay, and then you're going to have a little brief discussion. This is not a research paper. Just I think I have it that I try to keep it just like a page, and so I have a little example. Okay, so you're going to have a brief discussion of the oligopoly market that these two firms compete in, the ones you choose. Social media market, rideshare market, whatever it is. And you can mention if these firms, if applicable, follow a Cornell or Stackelberg model. And remember, like Cornell is if two firms kind of split the market. And, you know, like a Coke and Pepsi would pretty much be, I think both, well, maybe, I don't know. If you think both firms, it depends on what you think in your discussion. So if you think both firms are kind of equally competitive, then it would be Cornell. If you think one firm's a little bit bigger, like Microsoft is bigger than Apple in the software industry, then you would do the Stackelberg model. So if you think one of those models applies that we talked about to your example, you can talk about that. And then just simply, what are your expectations for these oligopolies and this market going forward? And this is especially important because the future of a lot of industries is very uncertain. So you can just, there's no right answers here, but it's a very relevant topic to look at different industries and how they might do in the future of this current economy. Okay, and so I said your oligopoly homework should be about 1 page with the equations and graphs, and I'll show you a nice little template of that. And if you do a PDF or Word document, that's preferred, like you guys have been doing. And we're going to do some data analysis in Excel, but you don't have to submit the Excel file, just the final Word or PDF. Okay, so we're gonna watch the example, but let me show you just kind of what it's going to look like when he's done. Under the oligopoly homework, I have my example here, the Word document. Let's open that. Alright, so here's what you can shoot for, and so you have a couple graphs of the historical data for both of the oligopolies you choose. In the first part, the data. Okay, and then you'll have a couple equations for the forecast, and I'll show you how to do this. So that'll go in the section 2 here. And then just a nice little paragraph discussion on what answering those questions and what's your conclusions from the analysis of the oligopoly that you were talking about. Okay, so try to keep it to a page like this. If you go over to page 2, that's fine, but I have to look at and grade all of these and the final and the 2 other homeworks by next Saturday. So try to keep it to a page just so I can get all the grading done. But if you have to go to page 2, that's fine. Okay, so this is the assignment we just went through. I'm going to show you how to get the data from Yahoo Finance, and then we'll go from there. Any questions so far on this? All right, so keep it start thinking about which of these either 5 examples you want to look at, or if you have a better idea, something different that's also interesting to you, you can run a different 2 oligopolies by me, and I'll tell you if that works or not. Okay, so the first thing you want to do is just go to Yahoo Finance and get the data for whatever companies you're going to do, and if you just want to watch right now, you're welcome to do that, and then you can look at the video later if you need more help with Excel. But let's first just go to Yahoo Finance. All right, it should be easy to find. You don't need a subscription or anything. You can just Google it and go to Yahoo Finance. Okay, and you should be able to search for any of those ones I suggested. All right, it's usually the first one, like the AMZN is Amazon. There's BABA, Baba is Alibaba. APL is Apple. And MSFT, it's usually going to be the very first one that comes up. Just click on that for whatever example. I'll end to check on. So Netflix. There's that, the NFLX, and let me see if there's a Hulu option. Doesn't look like it. Maybe somebody else owns Hulu, I'm not sure. But I don't see it as a separate public company here, so okay, it's owned by other companies, so don't do Hulu. It's not a separate company. Okay, so you should be able to find pick one of those 2 oligopoly competing examples, and you can search for those in Yahoo Finance. I prepared as an example Budweiser versus Coors, so let me get those. No, okay, here it is. Book PUD. All right, so you'll start with one of them. So here's one of my examples is Budweiser. So you click on the little page, and it takes you to the Yahoo Finance page for that stock or that company. All right, and then once you get here, you're going to click on the tab that says Historical Data. Okay, and so you want, depending on when your company went public, you want all the data in monthly frequency. So where it says time period, you can click on that little option, the drop down, and there should be a button that says max. Click on max to get the maximum data, all of it. Okay, and you want historical prices, and you want to change the frequency to monthly. Okay, so time period is max, historical data, and then monthly. And then if you click on this apply button, okay, that should do it. And then you click on, once it's done refreshing, you can click on the download button. Alright, and it should give you this file here that has these columns with the different prices and the volume and the date for whatever stock or company you're choosing to talk about. Alright, so everybody good on getting to this point? Just getting the date, getting your file? Alright, so you would start kind of, what you want to do is save it as an Excel file, and then you can officially have like two tabs, and one tab will be one of the oligopolies, and the other tab will be the other. Okay, so here's the first one, and then you would also want to go and get the other one. So I'm going to do Budweiser and Coors, so I'll search for the second one. TAP is for Coors. Okay, and then you want to do the same thing, go to historical data. Change the time period to max. And then historical prices, and then frequency is monthly. Okay, hit the apply button, wait for it to load, and then download this one. Okay, so I know it's going to give you the file in a CSV. It's going to give you the file in that format because it's easier to compress and easier for the file to be stored on the cloud or whatever it is. So you want to put your data into an Excel file, a .xls file, because you can do more features with that. So I'm just going to open up a separate or blank Excel file and then copy and paste the data I need into that. And so make sure you're working with an Excel file, because we try to do this stuff with a CSV file. I don't think you can do everything, and I think it doesn't save properly. So make sure you're doing with an Excel file. Just take the data out of your CSV file. Okay, so what I'm going to do is just show you how to get started here is you want to open up a blank Excel file, and then you can put one of the company's data on one tab, and then the other on the other. So I'll just call this tab my first stock symbol, which is BUD, B-U-D. Okay, and then the other one is TAP for cores. And so all you need into these, for now, just to start with the data, you can, okay, so I think the easiest thing to do is to copy and paste the data we need and put it into the Excel file we're starting. So you want the date, and you want the closing price, and that's it. All the other stuff you don't need for this assignment. So I'm just going to copy and paste column A. Okay, so I have the date, and then I'm going to copy and paste the closing price column and put it right next to the date, and that's all you need from your first company. Okay, I'm gonna save this just in case. Alright, so make sure when you save it, you're working with an Excel file, because Excel files you can do much more, and it saves it properly. So we got the first company right here with the date and the price, closing price, and then I need the other one. Okay, so I'm just going to copy and paste the date column and then the closing price. Okay, so this is what your starting data sets will look like. You'll have one company on one tab, and so here's the Budweiser company with data from 2009 to 2020, right? And then it looks like Coors has been around since 1975 with Publix then. Okay, so this is what you need to start with. So any questions on just getting to this point, getting the data ready to go with your an Excel file with the date and the closing price for each company? Okay, everyone's good on this?
Yes.
Okay. Hold on. Okay, so step one, we're halfway done with that. So you get all the monthly data for both stocks. All right, and so remember, you're just gonna pick one of these two options, or one of these 5 options up here. Okay, so if you choose that one, you want to get the data for Amazon, Alibaba. If you choose this one, you want to get the data for Apple and Microsoft. So only get the one you choose, and pick whichever one you think is most interesting. Or if you have a different suggestion, you can run that by me and choose something different. Okay, so the only thing you can't choose is Budweiser and Coors because that's my example. Okay, so you got all the data, or we did. Okay, you put it in Excel, and let's finish off step one and get time plots of the closing price over time, so you can see what's happened historically for both of the companies. Okay, so getting your time plot's pretty easy. You just want to select all the data that you have. So this, and let me just. Okay, so you should see that your data goes up to the current month, which is August, and then therefore, assuming that's correct, you're going to try to predict, or just not predict, but just use some simple forecasting methods to see what you think the next month's price will be, which is September. All right, so there's a good chance you will be completely wrong given the unpredictability of the economy right now. But so you want your historical data to go up to 8/1/2020, and then this is you can delete this one. That was a repeat of yesterday's date, and then just make a note that you're trying to calculate or predict next month, which is 9 September. And so this is all actual data, and then this is the one you're trying to forecast. All right, and this is the closing price of a stock share in actual dollars. So if you want, you can format the closing price column with the currency, just like with a dollar sign, so it makes more sense of what you're looking at, the actual price. And you can go to format and format cells. And if you want, you can change the category to currency with the dollar sign and the decimal places of 2. All right, so there you go. You have the actual closing price in dollars of whatever the company is, and the first date will be the first month that your company went public, and then the last date should be August, and then you're trying to forecast or predict September. Okay, so to make a time plot of the closing price over time, you can just select all the data, so you can hit Control A. Control A, select all, at least for Windows. And then to make a time plot, you can just go to the Insert tab. And then let's try recommended charts. And let's do that one. So the line chart, which shows kind of what the price has done historically, each month. That's the one you want. You can hit OK. Alright, so again, there's many different, you can do, like, there's all kinds of different colors and styles. Up there, you can be creative if you want. I'm just going to stick with the basic one, but there's all kinds of options that you can look at, and just make sure you put a title on it for when it goes into your final document. So this is the closing price for Budweiser. Okay, and you can see that at least in the last 3 months, they're not doing too well. Okay, then you want to do the same for the other company you chose. Alright, so for Coors, I'm going to delete if there's two August observations, like it looks like there is, you can delete the repeat one. And then put in the September month that you're trying to forecast. Okay, and then again, I'm going to pull out the currency, the closing price, column B, in the currency, so it looks like dollars. Alright, so there's the closing price in dollars of a share of Coors stock. Yeah, and then you can make another time plot of your second company. The same way, select it all. You can Control A. And then again, insert recommended charts. To choose the line one and hit OK. Okay, there we go. There's the other one. All right, so this is basically step one. We want to get the closing price, doing all the data in both tabs for both companies, and you want to get a time plot of the closing price over time for both the companies. So here's the time plot Budweiser, here's a time plot. Of course, and so do that for both of your companies, so you can put them side by side and compare them. Depending on the industry, you might see a downtick in prices in a recent time period, like I am here. So it looks like the domestic beer market isn't doing great in the last few months. Okay, and that's step one. Yeah. Okay, and again, once I finish this, doing it when we're doing it together, I'll post it on the Blackboard so you guys can look at it as an example. Any questions so far of what we've done? Okay, so yeah, you just have to repeat this for your example. Okay, so the next step is to do a little data analysis, and so I'm going to show you how to do a moving average and simple exponential smoothing for the two examples. And so I think you'll get the idea of what the models are when we do them in Excel. But there's an actual video if you want to look at this later. So in the video section on our Blackboard page, I think I have a video for these two models. Yeah, so this is like a 10-minute or so video that explains more detail on exponential smoothing and moving average and how it compares to just a normal average. So you can look at that if you want to get some more explanation. Okay, so what we're going to do in this step is estimate a few simple forecasting models for both of the two types. And I'll show you how to do that, and you can use my example, but you want to repeat this analysis for the two companies that you choose. Okay, so we'll start with a moving average. Okay, so we'll just do this manually in Excel, and you should easily be able to replicate this for your company. I'm going to move over the graph a little bit so I can work with the columns. Okay, so we're going to do a moving average, and a moving average is just simply instead of taking the whole average, you're moving the average. And so, like, you'll see what I mean when we do it, but if I took the average of this whole thing, then you would just add up all the numbers and divide by the number of observations, just like an average. But a moving average you might use because the average isn't good for data that changes so frequently. And so a moving average, you move the average by a certain specification. So, for example, an MA2 or a moving average of 2 would just take the average of the last two observations. So let me show you what that means. So you need at least 2, but if I started it here, Okay, so see how it's just the average of the last two observations in MA2? Okay, and the reason why it's called a moving average is because you move it. And so see if I went to the next one, this is the moving average of the previous two. I guess I would start it here. So if I started in the C4, so the average of the last two would be a moving average of 2. Okay, so then the next moving average observation is the average of the previous two. So see how we're moving it one tick in the future. So we keep moving the average, but taking the average of the last two observations. You can take different moving average orders, like an MA3. Okay, and you can probably guess what an MA3 is. It's the moving average of the last 3 observations. So to do this, you would have to start in the 4th cell. Okay, and that's the average of the last 3. And you can keep moving this. So the average moves, but it's always the average of the last 3 observations. So it's not the average of the whole thing. It's the moving average of the last 3. And you can do any number you want. You can do MA2, MA3, MA4, etc. Okay, so I think you see what we're trying to do here. And so we're going to do a moving average process and compare it and see how it looks for the closing price for your company. So I think I normally do an MA2 for this example. Let me see what I did. Yeah, we did MA2. Okay, so we can. I'm going to choose the MA2 for this project, and you can choose a different one if you want to, but it's probably easier if you just choose the same one. And so let's stick with the MA2 because it's the simplest. Okay, so let me start with. So do you see what the moving average technique is doing? It's pretty simple, but just to clarify. All right. So we'll start. I'll show you the estimated MA2 for this example. Okay. So you got your data here. You got your date here, your closing price here, and then you can label column C when you do this. MA2 for a moving average of 2. Okay, and remember you have to have at least 2 past observations to start this process. So that means let's start in cell C4 because we can't start the moving average until we have at least 2 previous observations. So starting here in C4, just you type it in Excel equals average. Alright, so equals average of B2 to B3, so the previous two, or the first two. Alright. Enter. And then you can repeat the same process, but you can just have Excel do it for you. So you can just drag it down like this. When this one says equals average of B2 to B3, just select C4 again and grab the bottom right corner, and you can drag it down to the end. Okay, like that. So you keep moving that two-order average all the way to the most recent observation, and then you can see that your moving average forecast is just simply the average of the last 2 months. So when you get down to the moving average of 2 for September, you should see that it's just the average of the price in July and the price of August, because it's a moving average of 2. You're just moving it one iteration in the future. Okay. So, questions so far on what we did with the moving average? Okay. Because you'll probably have quite a bit of rows. I'm gonna make it so you can you can see the top titles. So if you want to do this, it makes it easier to see which column you're in. If you click on the View tab and the Freeze Frames option, and if you want to freeze top row, it makes it a lot easier to see where you are. So see, you can go all the way down and you're in the same. You can see which column you're in at the top. Okay, so a few more things with the moving average, and to go back to the assignment part. All right, so for each of the companies, you want to do the moving average with the one month forecast, which we did, which will be the forecast for September. And then you want to include the equation, which I'll show you to do, and then you want to calculate the mean forecast and the MAPE, which is the mean absolute percentage error. And so these are statistical terms, but they're pretty easy to calculate in Excel. So let's first do the mean forecast error. Okay, so let's just call column D. In D1, this is going to be just the forecast error. Let's just call this error, or the standard error. Okay, error. And then the error is real simple. It's just the difference between what your moving average forecast gave you and what actually happened in the data. So it's just the variance between the actual data and the moving average. So just starting in V4 equals V4 minus V4. So just the difference between what you calculated with the moving average and what actually happened in the data. So just equals V4 minus V4, just the difference. And then you can drag that same formula all the way down the column. So grab the formula in V4 and drag it down to the bottom. Okay, so your last one should be the error in month August. Okay, and then right here in column, and you're gonna have a different number of rows depending on how much data you have, but right below in the bottom of the error column, you can calculate the average error, which is just simply the average of the D column. So it's pretty easy, but just equals average. Okay, average of all the errors. So starting in D4 and then all the way down, you want the average. Okay, average of D4 to D135. You'll have a different number of them because all the months are not going to be the same, but go from the first one all the way to August. Okay, and your error should be somewhere around 0. If it's, like, mine's pretty close to 0. If yours is like a 0 or a dollar, if it's way off, if it's like, $100, then something's probably wrong. So just look at it and make sure it's somewhere around 0 because it's supposed to fluctuate around 0. Okay, and then the last thing you want for the first moving average is the MAPE, which is the mean absolute percentage error. All right, so let's call column E APE, or absolute percentage error. Okay, you might be familiar with this term from any statistics course, but it's just you're calculating exactly what it says, and so you want the absolute value of the percentage error. Okay, and so we can do that. I think you want to make column E formatted as a percentage first. Okay, if you click on column E and then go to the format, or I think we can do right here. Yeah, if you format column E to be a percentage, you want to do that. Okay, and you just need to write the first formula, and then you can drag it down like we've been doing. So in E4, you want to specify that you want the absolute value the percent off, or the percent error. So this is just equal to, that ABS formula is the absolute value, and then you want to specify that you want how far off the moving average was from the actual data. So it's just actual data minus the moving average divided by the actual. So basically, actual minus forecast divided by actual. So in our case, that's B minus C over B. Alright, so put a second parenthesis there, so double parenthesis. Okay, so that's what you want. Equals absolute value. B4 minus C4 over B4. So see, this is just like the percent off that the MA was from the actual. So how far off was 41.78 from 45.94? So it's just the difference. Okay, B4 minus C4 divided over the original. Okay, so this minus this over this. That's the percent off. So your formula is equals ABS, double parentheses, B4 minus C4 divided by B4. Okay, and then you can say that the first one was about 9% off. Okay, and we want to do the same calculation for the whole data set, so you can drag it down, click on E4 and drag it down to the bottom last to August. Okay, and this last one should be the APE for August, and then you're going to calculate in the next column, right here, you're going to calculate the average, and the average is the APE, which is the absolute, or it's the MAPE, which is the mean absolute percentage error. Okay, so mean just means average, so in right below your last August one right here, I'm just going to calculate the average of the whole column. So equals average. Okay, so you just simply want the average of all the APEs, which is by definition the MAPE. Okay, so there's the average of all those APEs, the whole E column. Okay, so yours will be different, but on average, the MA2 process was about 6% off in the actual data. Alright, so before we do the next forecasting method, let me just, alright, so we've done this part. Moving average with the 1 month forecast, the mean forecast there, the MAPE. And so let me just make a note of what we've done, because you're going to put it into your final document when you're done doing the data part. Alright, I'm going to give the moving average section its own color so I can separate it from the other one. Let me see what I did before. I'll make the moving average blue and the other one like the orange color. Okay. Okay, so this is our moving average stuff that we've done, and you can make a note of what this is. So this is the this number 54.34. That's the moving average of 2 forecast. This is the average error. Okay, or the mean forecast error. Okay, and then this is the MAPE. Okay, so here's the MAQ forecast right there, 54.34. Here's the mean forecast error, 14 cents, and then the MAPE is 5.92%. Okay, so now we're going to do the other one, the exponential smoothing. Everyone good? Any questions so far? Okay. All right. Next step is to do the simple exponential smoothing, and so we're going to do one more method and look at the errors, and then you're going to do this for both of your companies. Okay, so the F, G, and H column are going to be for exponential smoothing. So I'm going to make this a different color. Okay, so the exponential smoothing method puts some weight on, so it's another variation of the average where you put some of the weight on what just happened and then some of the weight on the previous forecast. And so let me just show you the simple formula. Okay, so here's, well, I want to show you the general formula. Alright, so it looks something like this. This is an output, I'm going to explain it. So it's a simple formula where you have an alpha, which is how much weight you put on the previous observation, and then a 1 minus alpha where you put the rest of the weight on the previous forecast. So it just looks like this, where your exponential smoothing is equal to alpha times the last observation plus 1 minus alpha times the last forecast. So that's all you have. That's where your formula is going to come. And so you're deciding how much weight you want to put to what just happened, and then the rest of the weight goes to the previous forecast. So it's a good way to deviate from the average if you think that what's happened recently is a better predictor of just the average. Okay, so see how I put the formula in here where my exponential smoothing is alpha, which in this case is 0.9, and then it's multiplied by the last observation. Okay, and then the rest of 1 minus alpha has to be 0.1. Right, 1 minus 0.9 is 0.1, and then that's multiplied by the last forecast. So this is what you see. Okay, so we'll tell Excel to do something like that, where it's going to be, we'll use 0.9 to be consistent. So 0.9 times something plus 0.1 times the rest. Alright, so let's go back to the data file, and we'll do the exponential smoothing part. Okay, let's call column F. Let's call this this is going to be exponential smoothing, so let's call this alright, we'll call that exponential smoothing, so EXP smooth. Okay, and we're just going to specify the simple equation, which is alpha times the last observation plus 1 minus alpha times the last forecast, which we're going to design. So you need to just start with the first piece of data, which is, again, D2. So in E3, just type in equals B2. So you want to link in, so in F3, just type in equals B2. Alright, and then we'll start the calculation here. So in F4 equals alpha, which is going to be 0.9, okay, times the last piece of data, which is B3, and then plus, and 1 minus alpha, which is 0.1, times the last forecast, which is F3. So this is, you want to make sure your equation looks like this in the first one, and then you can apply it down the column. So this is an exponential smoothing, and you have an alpha of 0.9. Alright, so this is what the alpha means, essentially, numerically, is that we're doing exponential smoothing. We can choose different alphas, but we chose 0.9 for our example. And so alpha is 0.9, and that means that's the percent, or it goes from 0 to 1. So if it's 1, then 100%, then it's just the last observation exactly. And if it's 0.8, it's 80%. So because it's 0.9, we're saying that 90% of the weight is given to the last or previous observation. Okay, so you can change the alpha by doing that, but that's what this alpha 0.9 means. Okay, so to go over, let's make sure that in the F column, in cell F3, this is equal to B2. In cell F4, this is equal to 0.9 times B3 plus 0.1 times F3. Alright, and then enter. And if you have this formula set up correctly, then you're going to drag it down all the way to the end to get to all your exponential smoothing calculations. So just take F4 and drag the formula down like this. Alright, and you can see that your September forecast is 0.9. It should be 0.9 times the last observation, which is 54.26 for this data, plus 1 minus alpha, which is 0.1 times the last forecast, which is 53.89. Okay, so this is the actual forecast. So $54.22. All right, and then this is the exponential smoothing forecast. Okay, so we're going to do the error measures for this. But questions on this? How to calculate the exponential smoothing? Okay. So I have a question, which says that I don't know how you find 0.9 where that is the last option. So let me. All right, let me just clarify real quick how we're getting from the general formula to what we're doing. Okay, so then I'll show you how the alphas change. Okay, so this is just the general formula, which is ft equals alpha times yt minus 1 plus 1 minus alpha ft minus 1. And this simply means that your forecast for ft, so this is like alright, so ft for us is the September forecast. Okay, so we're saying that our forecast is calculated by, or any of the forecasts, but alpha times yt minus 1 plus 1 minus alpha ft minus 1. And so alpha is between 0 and 1 because it's got to be either 0.1, 0.2, somewhere between 0 and 1 to specify the weight. And ft is the forecast, or the last one is September's forecast. And yt minus 1 is the previous month's price. And ft minus 1 is the previous month's exponential footing forecast. So I just chose an alpha to be consistent, but you can do different alphas and you can specify different equations based on what you think your alpha should be. Okay, so that's the one we did as an example. You could change the alpha, but that would also change the 1 minus alpha. So if you wanted to get creative, you're welcome to use a different alpha. Okay, so if you chose an alpha of 0.8, then that means your 1 minus alpha is what? 0.2, right? Okay, so this is the idea that you're specifying the alpha because this is how much weight you put on what just happened. Okay, so if the alpha was 1, then it's just equal to what just happened. But we specified alpha of 9, which would be 90%. And so you want to, this forecasting method is used because if you think which is likely that what happened recently is more important than what's happened on average, you can use this to give more weight to what just happened, like this alpha. But you still want to give some weight to what's happened in the historical data. So changing alpha does this, and you can use any alpha you want, but this is how it works. Okay, and so the reason I chose this one is because it's more likely that stock prices are unpredictable, and so giving a lot of weight to what just happened, like often the best guess is what just happened, and so that's why we did this. Okay, so does that make sense? Okay. Okay, I can I can put, do you want me to, let me save this. Okay. Let's go back to the Excel spreadsheet. Okay, now so to finish the analysis here, you want to get, we've got the exponential smoothing forecast for month September right here. Okay, and then we just want to get the error and the APE for the exponential smoothing. Alright, so again, I use, you don't have, I use alpha equals 0.9 as the example. You're welcome to use alpha equals 0.9, or if you want, I explained how you can change the equation if you wanted to. So if you feel like choosing a different alpha, you can. But if you want it to be consistent, you can just use the 0.9. So it's up to you. Okay, we need the forecast error, so starting in G3 equals B3 minus F3. Okay, so it's just the difference between what happened in the reported price and the forecast. So it's going to be like $3. Okay, equals B3 minus F3, and you want to just calculate the difference all the way down, let's call this error. And H will be the AP when we get to that. Okay, but this in G3 is equal to B3 minus F3. And you can apply the same calculations on the G column, just to take G3 and drag it down. Okay, so there's the last one for August. And for this one, you want to also calculate the mean forecast error. Alright, which is just the average of the whole G column. So right here, I can just take the average of the errors equals average. Okay, average of everything up to August, and hopefully it's something like 0, or close to it. Pretty good. And then we need to calculate the APE in the H column. Alright, so the APE is again the absolute percentage error, and you would calculate that the same way, which is the absolute value of the percent off from the forecast from the actual price. So in H3, you can write the first formula. Equals ABS, and then you can add a second parenthesis. Alright, and so there is the formula equals ABS double parenthesis B3 minus F3 divided by B3. Alright, and that's going to give us so how far off the actual was, the forecast was from the actual, so the difference over the original data. The absolute value is B3 minus F3 divided by B3, and enter. And I forgot, you want to make the H column in percent. So I'll format column H to look like percentages. Alright, and so maybe get this one here. In H3 equals absolute value of B3 minus F3 over B3. You can just apply the same formula down the H column to get all the APEs. Okay, so you can see what happens when there's a drastic change in the data. So see what happened here when the price dropped in 1 month. It dropped like $20 almost. So you can see how. Oops, sorry. You can see how in months. This is what's happened this year. It's crazy stuff. In February and March, the predictions were way off because the change in the price was so unpredictable. So the price went from $75 a share, and in the next month it was $58 a share, and the next month it was $44. So you might see that weird things happened in the first few months of this year because weird things did happen, and still are. Alright, and then you want the mean absolute percentage error here, which is just the average of the APE column. So right here I can calculate just the average of the H column. Alright, so there we go. So for Budweiser, for the first company, I have the analysis, the data part done. So I have historical data from all the way up to August, and then this is the MAT forecast, $54.34. This is the mean forecast there, 14 cents. This is the MAPE for that one, which is about 6%. And then here's the exponential smoothing forecast. $54.22. Mean forecast, which is 12 cents, and then the MAPE, which is 5.36%. So depending on whatever two companies you choose, your numbers are going to be different, but the calculations or the formula should be the same. Okay, so any questions so far? Is everyone good on getting the data, doing the two types of forecasts with the errors, and then you got the graph that we got the first time. So everyone good? Okay. All right. So we did the moving average, we did the exponential smoothing, and so you want to do that for both of your companies. All right. So I will post. Well, I've already I posted my completed one, but it doesn't have the last few dates or a few months. But so on the Blackboard side, you'll see this one for my example. So I have an example on Blackboard where I have the complete analysis for the time I did this for the last class, which is I did the same thing, but there's a few more months now. So here's the stuff we just did. It goes up to June, so we just added a few more months. And there's the one for course. Okay, and then I'll post this one as well for the one we just did, so you can see that. And so you have to do it for both. Okay, so does everyone want me to repeat the analysis for the second company, or do you guys got it? So I can do it again for the other example, or because you have to do two of them. Or if you've got it, we can add to it. Should I do the second company, or do we got the idea? Okay. Well, it looks like you know what to do. So I will post I'll post my data, so you can look at that for an example. But you just got to repeat that same analysis. Get the two different types of forecasts on the graph for both of your companies. Okay, and then the only thing you have to turn in is something that looks like this. So this is the example I have on Blackboard, and we have the two graphs of the historical price over time. Okay, and then you want to put in the forecast. So just put this part in for the last so here's this is just from Excel. So yours will be for September. So you have the September moving average, the September mean error, and the September MAPE for both of the types. Okay, and then I just want you to put the calculation for the two forecasts. So the moving average is going to be the actual calculation, which is just the average of the last two observations. So you would just be here. Let me just here. All right, so I'll do this for this one, but so just put in your first graph up here. Okay, and then you want to put in for both companies. I'll just do one, but you want to put in your forecast and errors, and just put the calculation how you got it. So just I know how you understand the formula. Okay, so you want that. There's the MAT forecast. There is the mean forecast there, and there's the MAPE for September. Well, the error parts are for the whole data, and the forecast is for September. But just specify the equation for the actual September forecast. So for this one, all right. So all we did was calculate the average of the last two observations. So you know how you get this number. Go back to the data sheet. And it's just 54.43. Plus 54.26. And just divide by 2 to get a moving average of 2. Okay, and that's how I got this number of $54.34. All right, and then you just want to specify it for the exponential smoothing one. All right, so I'm just going to copy and paste this. All right, and then just write out the equation for the exponential smoothing, and then that's it for this part. Okay, so just to show how you got this number, how I got 5422, is it's 1 minus alpha, which is 0.9. I mean, alpha is 0.9. Times the last observation, which is $54.26. All right, and then plus 1 minus alpha, which is 0.1. And the last forecast, which is $53.89. Okay, and that is how I got the prediction of $54.22. Okay, so that's what you want to do for this part, or for this assignment is alright, so you got the data. You want to do the forecast in Excel for both of the companies. And then you want to have a little discussion at the end. So here's okay, so you want the two graphs of the historical closing prices, and then do this part for both of the companies. And then down here you have a discussion. Okay, and that's pretty much the assignment. So all you have to turn in is the final document with the graphs and the forecast and equations and then the discussion. You don't have to submit the Excel file, just this part. Okay. Any questions on what you need to do for this assignment, for the oligopoly homework? Okay. Well, if you have any questions, right? No Excel file, just a Word PDF file. Yeah. Yeah, the deadline is Thursday, 8/13. So yeah, specified on the syllabus. Yeah, so this is due on Thursday, August 13th, and this goes into the oligopoly discussion forum here. So just post your Word document or PDF right there, and then that's it. Okay. So, any more questions on this assignment? Okay. Well, if you have any questions on this, you can let me know with the Excel or any of the other analysis. Then I'll post the stuff that we just did together as an example, so you can look at those. So you can look at my Excel file, and you can look at the Word file for examples of that. Oh, so it's already 10. Okay, well let's take a break because it's we went past our 10:30 mark, and then so let's take a break. We'll come back at 10:41. We'll come back at what 12 or 11:10 or 11:15. What? Okay, so we're all right. So we'll get on the oligopoly homework. We'll take a break till 11:15, then we'll do the review for the final, and then I'll give you guys the final, and then that's it. All right, so I'll see you guys. We'll resume at 11:15. Okay, we ready to resume? All right. Okay, so let me just all right, great. And so I put the files we just did together, the examples, I put those on Blackboard in case you need those to look at when you're doing yours. So if you go to chapter 10 on Blackboard, and there's a bunch of stuff here, but if you scroll down to the bottom, where it says oligopoly resources for today, Saturday, August 8th, I put the little exponential smoothing thing I did with the equations and the different alphas, if you want to look at that. I put the sample Word file with the graphs and the equations and the discussion. And then I put the Excel file if you want to look at that. So the stuff we just did together in class with the example, you can look at those if you need those when you're doing your assignment there. Alright, and again, so that goes there, and that's due next Thursday. Okay, so the last thing we have is to go over the practice exam for the final, and then I'll post the final exam, which is also due on Thursday, and then that's it. So you only have a few more things to do, but remember everything is going to be, these last two big assignments got to be in by Thursday, so I can get your grades in by Saturday. Okay, so let's do the review or the practice exam for the final. Okay, so if you go to Blackboard, if you go to final exam summer 2020, Alright, so we got a practice exam here, and we'll go through that, and then once we're done with that, I'll post your final right here. Okay, so here's the practice exam. So it's similar to the homework assignments you did, so you should have lots of practice on these types. Alright, so I think there's 3 big questions. One on chapter 10, no, one on chapter 8, and one on chapter 9, and then one on chapter 10. So there's the 3 homework assignments you did for chapter 8, chapter 9, and chapter 10 should have you prepared for these. So there's okay, so we got one big question on the profit maximizing choices in the different market structures from chapter 8. We got one on the Cornell and Stackelberg from chapter 9, and then we got the last one, chapter 10. Question number 3 is on the game theory. Okay, so 3 big questions. We'll go through my solutions here, and then your final will be similar to this. So, similar to the homework that you did for the chapters. Post midterm, just maybe a little bit longer. Okay, so you can open up the solutions for the practice exam. Okay, so here we go. The practice exam, this is a review for the final with my solutions, which are posted. You can see those. So here we go. The first question will be a big, similar to the chapter 8 homework on profit max. With different market structures, you'll have to do the profit max problem and then identify the type of market structure. Okay, so the following describes the firm's total cost, I plus Q squared, and the firm's a price taker, and other firms price at $9. What price should the firm put on this product? So a price taker, it's going to be priced at $9. Alright, what level of output should be used to maximize profits? You know, you're always going to follow the rule that you use thus far, which is the profit maximizing rule is MR equals MC. So you need to find MC, total cost, that's given, and then if you differentiate that with respect to Q, that is marginal cost, which is just 1 plus 2Q. Okay? And for a price taker, you know that's got to be a perfect competition situation. And if that's the case, that price equals marginal cost. Price is 9. That equals marginal cost of 1 plus 2Q. And then all you got to do here is solve for Q. Alright, we get 2Q equals 8 divided by 2, and Q star is 4 units. Alright, and then you know you're going to check if the firm should keep producing or shut down, which is if the price is bigger than or equal to the average variable cost at Q star. And so that's the price is 9. Average variable cost is Alright, so there's the variable cost, Q plus Q squared, so that means that variable cost is divide that by Q, so it's 1 plus Q. And 1 plus Q star of 4, which means that the price 9 is bigger than that average variable cost at Q star, so the firm's going to keep producing. And you can calculate profit or losses. Okay, that's just total revenue minus total cost, which is the price of the good times the quantity, and then minus the cost function at Q star, 5 plus Q squared. Price is 9, quantity is 4, minus 5, minus 4, and then minus 4 squared. And then I'll simplify to 36 minus 5 minus 4 minus 16, which is $11 of profit for this firm. And you should know from just the price taker aspect that this firm sells kale, which is a perfect substitute at a farmer's market. And what type of market is this? It's going to be perfect competition. Okay, so remember there's 4 markets to choose from: perfect competition, oligopoly, monopolistic competition, and monopoly. So just identify which one the example is. Okay, so question number 1, continue. There's a lot of parts, but you had practice on this. So there's A, B, C, D, E. So part F goes to the next example. So the second part, describes the firm's demand and total cost. Where here's demand, P equals 61 minus 2Q, and here's total cost, 1,000 plus Q squared. Okay, let's find the output to maximize profits, which is where MR equals MC. Okay, so you're going to find the MR and MC. We'll start over here. Total cost is given. You differentiate that with respect to Q, you get the marginal cost of 1 plus 2Q. And here you got to calculate the total revenue of price times quantity. And price is the demand curve, 61 minus 2Q times Q. Distribute the Q, you get 61Q minus 2Q squared, and then differentiate that with respect to Q, and you get MR. So it's 61 minus 4Q for MR, and let's set these two equal. MR equals MC is 61 minus 4Q equals 1 plus 2Q, and that means that you move things around. 6Q equals 60, divide by 6, and you get a Q star of 10. Okay, what's the market price? Just plug the quantity into the demand curve, so you get 61 minus 2Q, and 61 minus 2 times Q star of 10, and that gives us 61 minus 20, which is $41 for the market price. And we're going to check if the firm is going to keep producing or shut down. All right, is the price bigger than average variable cost at Q star? Average variable cost, again, is 1 plus Q. If you divide the variable cost of Q plus Q squared divided by Q, that's 1 plus Q for average variable cost. All right, so is 41 bigger than 1 plus Q star? It definitely is, because 41 is bigger than 1 plus 10, which is 11. and the firm's going to keep producing. All right, let's calculate profit or losses. That's total revenue minus total cost. Okay, and price times quantity is 41 times 10, and minus the total cost of 1,000 plus Q plus Q squared. We got price times quantity minus 1,000 minus 10 minus 10 squared, and then this simplifies to 410 minus 1,000 minus 10 minus 100. And if you notice, this is a loss minimization situation. So P profit or pi star is negative 700. Okay, but you still did it correctly, because if you compare that to the sunk cost or the fixed cost, right, if the firm were to just shut down, they would lose 1,000, but continuing to produce, they only lose 700. So this is, it's not ideal, but it's a loss minimization, because producing and taking a loss is better than shutting down and losing more. So they're minimizing losses, and their loss minimization is negative 700. Okay, the firm sells razors and competes with other firms selling slightly differentiated razors. What type of market is the firm operating in? And so this is a type of market, the razor market. And you can see they're slightly differentiated. So there's lots of different sellers of razors. You have a few big companies or a few general companies, then you have generic razors. But this is definitely a monopolistic competition market. Okay, one more part of question one. Following equation describes the firm's demand and total cost. So you got the demand function, 101 minus Q, and then the total cost of 5 plus Q plus Q squared. Okay, what level of output should be produced to max profits or minimize losses? Okay, you need MR equals MC. Total cost is given. If you differentiate that with respect to Q, that's marginal cost, 1 plus 2Q. You can calculate total revenue at P times Q. And that is the demand curve, 100 minus Q times Q. 101 Q minus Q squared is total revenue. Differentiate that with respect to Q, and you get a marginal revenue of 101 minus 2Q. And let's set those two equal, MR equals MC. Solve for Q. 4Q equals 100, and that comes out to Q equals 100 divided by 4, and that gives us a Q star of 25 units. All right, what is the market price? Put that in the demand curve, 101 minus Q, and that's 101 minus a Q star of 25. So a price of $76. And is the firm going to keep producing or shut down? You have to check that. Where P star is bigger than or equal to the average variable cost at Q star. And again, the average variable cost is 1 plus Q, which is that part variable cost. Q plus Q squared divided by Q is 1 plus Q. Alright, is 76 bigger than 1 plus Q star, which is 1 plus 25, and it is because 76 is bigger than 26, so the firm's going to keep producing. Let's see what their profit or loss situation is. Revenue minus cost. So revenue is price 76 times quantity of 25 minus the total cost function of 5 plus Q squared. M is price times quantity, put in the Q star of 25. So we have minus 5 minus 25 minus 25 squared. That gives us 1,900 minus 5 minus 25 minus 625, and that gives us a profit for this firm of $1,245. Last part O. This is a public firm which picks up trash and recycling. No other businesses offer this service in the city. What type of market is this firm operating in? So you should know that pretty much all public utilities are monopolies. N, it says that no other firm or business offers this service, so that means they're the only firm, only provider, which means they are a monopoly. Okay, so I think you guys have had practice on question number 1. This will be one big one like this. When I grade your homework for chapter 8, most of you did pretty well on that one, but I'd say that the one things that to pay attention to are some people did the average variable, like to check if T star is bigger than average variable cost. Someone did that. Some people did that a little weird, so make sure you double check on that condition, and then just make sure you identify the right market. And other than that, you guys did really well in this type of problem. All right, so there'll be one of these on the take-home final. Any questions on question type number 1 for chapter 8? Okay, yeah, looks like we're good there. You're probably tired of doing that, but you only got to do one more time and then you're done. All right, so question number 2 on the practice final and the real final is going to be on chapter 9 on the Cornell Stackelberg example. All right, so here we go. Suppose the inverse demand function and the cost function for 2 duopolists is given by, here's the demand function, P equals 44 minus Q1 plus Q2. And the cost function for all the firms is for Q1 is 4Q1 and C2 is 4Q2. Okay, so you got to do this for the Cornell first, and then for the Stackelberg version. So assume 2 Cornell duopolists. What's firm 1's quantity and profit? What's firm 2's quantity and profit? And what's the market price? Okay, so this one is similar to the homework for chapter 9. I haven't graded those ones yet because none of all of them are turned in yet, but you should be, if you knew what you were doing on that one, you should be good for this, but similar to the homework for chapter 9. Okay, so get the revenue of both firms. R1 is the demand curve, 44 minus Q2 minus 44 minus Q1 minus Q2 times Q1, and then do the same for firm 2. Alright, so this one simplifies the 44 minus Q1 squared minus Q2 Q1, and for firm 2, it's 44 Q2 minus Q2 squared minus Q1 Q2, and differentiate both with respect to that firm's quantity, and it gives the MR for that firm. So MR1, differentiate R1 with respect to Q1, and you get 44 minus QQ1 minus Q2. For firm 2, differentiate R2 with respect to Q2, which gives you MR2 of 44 minus 2Q2 minus Q1. Alright, to find each firm's reaction function, to do that, you gotta set MR equal to MC for both firms. So it's MR equals MC for 1 and 2. Okay, MR is 44 minus, you calculate that, 44 minus 2Q1 minus Q2, and then marginal cost. All the cost functions are just 4Q. So if you differentiate those with respect to Q, this is 4, so all the marginal costs for this example are 4. Okay, so MR equals MC for both firms. And you just want to solve for Q1 over here. 2Q1 equals 40 minus Q2, and you want to solve for Q2 over here. So 2Q2 equals 40 minus Q1, and then firm 1's reaction function, solving for Q1, is 20 minus 1 half Q2. And firm 2's reaction function, solving for Q2, is 20 minus 1 half Q1. Okay, so to solve, to get Q1 star and Q2 star, just plug each firm's reaction function into the other, because you get two equations with two unknowns you can solve for. And you get 20 minus 1 half times, that goes in there. 20 minus 1 half Q1, and then for firm 2, 20 minus 1 half, for firm 1's reaction function, 20 minus 1 half Q2. And then over here, solve for Q1 equals 20 minus 10 plus 1/4 Q1, and then over here, solve for Q2, 20 minus 10 plus 1/4 Q2. Do some algebra, you get 3/4 Q1 equals 10, and 3/4 Q2 equals 10, and multiply everything by 4/3. Q1 equals 4/3 times 10, Q2 equals 4/3 times 10, and you get, what do we get? Q1 star is 40 over 3, which is approximately 13. And Q2 star is 40 divided by 3, which is about 13. Okay, so you should get the same quantity for both Cornell firms. Alright, and then put the two Q's, the Q1 star and the Q2 star, into the demand function of 44 minus Q1 plus Q2. So you get 44 minus 40/3 minus 40/3, and that gives us 52/3, which is roughly 17 for the price. Then just get profit of firm 1 and firm 2, which should be the same for the Cornell firms. Price times quantity minus cost for both firms. Price is 52/3. Quantity is 40 over 3. And the cost function, remember, is just 4Q. So it's 4 times 40/3. And so you should get the same profit for both, which is approximately $178 for both Cornell firms. Okay, now you got to do the Stackelberg analysis. So now assume they're a homogeneous product Stackelberg oligopoly, where firm 1 is the leader and firm 2 is the follower. So find both firms' profit and quantity, and then the market price. Okay, so because it's the same demand curve and cost functions, you can start. You already know firm 2's reaction function because you calculated that in the previous part. Right there, Q2 equals 20 minus 1 half Q1. And you already know firm one's revenue because you already got that up here. R1 equals 44 Q1 minus Q1 squared minus Q2 Q1. Okay, so you can start with those two items if you don't want to calculate those again. And the first thing you're going to do, firm 1 goes first. Firm 1 maximizes profit using firm 2's reaction function. So firm 2 is going to react to the leader's decision. Okay, here's R1, 44 Q1 minus Q1 squared minus Q2 Q1, and subtract the cost function of firm 1, which is just 4Q1, that's given. That simplifies to 40Q1 minus Q1 squared minus Q2 Q1. And here you're going to put in, for Q2, you're going to put in firm 2's reaction function. So you get 40Q1 minus Q1 squared minus Q1 times 20 minus 1 half Q1. And then, simplify this to 40 minus Q1 squared minus 20 Q1 plus 1 half Q1 squared, and then the terms combine to 20 Q1 minus 1 half Q1 squared. Alright, so that's firm 1's profit function. You're going to maximize that by choosing Q1. Which means you just want to differentiate the profit function and set it equal to 0 and find that Q1. Because again, that's the point at which the profit function has reached the highest point. So differentiate profit 1 with respect to Q1, and you get 20 minus Q1. And if you set that equal to 0, just want to find that Q, which is Q1 star equals 20. Okay, now put firm 1's first decision quantity into firm 2's reaction function because they go second. So reaction function is 20 minus 1 half Q1, which is 20 minus 1 half Q1 star is 20, which simplifies to 20 minus 10, and then Q2 star is exactly half of firm 1's output, which is 10. Don't use the demand curve, 44 minus Q1 plus Q2. Put in the optimal quantity of Q1 star minus 20 minus Q2 star of 10, and that gives us a price, Stackelberg price of 14. Okay, then you can get both firms' profits, which is their price times quantity minus their cost. Prices are 14. Q1 star is 20, minus 4 times 20 for Q1, and then over here, price is 14, Q2 star is 10, minus their cost of 4 times Q2 star is 10. This simplifies to 200 for profit of firm 1, and the profit of firm 2 is just 100, and so you should see that for Stackelberg, the profit of firm 1 is double the profit of firm 2. Okay, so which of the 4 firms for G makes the highest profit and which one makes the lowest profit? You should get that the Stackelberg firm 1, a leader, has the highest profit. So this is 200. This is 100. And the other two Cornell firms made 178, so the highest is the Stackelberg leader. And the lowest is the Stackelberg follower of $100 profit. And then which of the two markets has the lowest market price? And you should get that it should probably be Stackelberg because that one's 14 and that other one was roughly about 17, so yeah, Stackelberg has a lower market price. Alright, so And we've had a bunch of practice on this type, the Stackleboard Carnot, and most of you have already done the homework for chapter 9, so you've had some practice on that one. But any questions on problem 2, the Carnot Stackleboard, for example? Alright, seems like we're okay with that. Let's move on to the last question, which is on chapter 10, game theory questions. Okay, so this should be similar to the chapter 10 homework, which is due today, but here's another example. Oligopoly, game theory. So let's assume it's 1985 and Nintendo and Atari play the following simultaneous move game. Nintendo has 2 pricing options for its Nintendo Entertainment System, and Atari has 2 pricing options for its new game console. Both can either price their new game consoles at 100 or 200. Those are the 2 options. If both price at 100, each earns profits of $1 million. If both price at 200, each earns profits of $5 million, and if one prices at 100 and one prices at 200, the company that prices at 100 earns $10 million, and the company that prices at 200 loses $1 million. So those are the strategies and payouts. So you can put Nintendo on the left side and list Nintendo's profits first, and Atari's profits second, and put Atari on the top portion. Okay, so the first thing we'll do is just draw the game. So it's a one-time game. Let's say Nintendo and Atari play the game only once. So first you want to draw the payoff matrix, and then you want to define the master equilibrium like we've been doing. So if they both price at 100, they both get $1 million. If they both price at 200, they both get 5, and then the person, if they mix, whoever prices at 200, they get undercut, and they lose $1 million, and the company that prices at 100 gets $10 million. So these are the options. And you'll see if you do the analysis without any collusions, both firms will have a dominant strategy of pricing at 100 because they don't want to risk losing the $1 million. So okay, so if Atari prices at 100, Nintendo can price at 100 and get $1 million, or 200 and lose $1 million. They're going to price at 100. Then if Atari prices at 200, Nintendo can price at 100 and get $10 million, or 200 and get $5 million. So both scenarios, their best response to their dominant strategy is at price at 100, and that's the same for both firms because this, matrix is symmetrical. So if Nintendo prices at 100, Atari can price at 100 and get 1, or 200 and lose 1. They're going to price at 100. If Nintendo prices at 200, Atari can price at 100 and get 10, or 200 and get 5. So given all the scenarios, both firms have a dominant strategy of pricing at 100. Okay, so you can define that master equilibrium as both firms price at 100 and both firms earn $1 million. So price at 100, price at 100, and $1 million, $1 million is the strategies and the payouts for the master equilibrium. Okay, then once they play the game with an uncertain final period, so we'll say Nintendo and Atari play the game repeatedly, and there's an uncertain final period. So there's a 5% chance of a union strike, which would end the game. And so furthermore, both would agree to price their new game consoles at $200, assuming neither company cheats on the agreement. So obviously, if you look at the payoff matrix, if they can both agree on 200, then they both increase their revenues to 5. If they can keep that agreement, that's much better than the $1 million they get by no agreement. So this is the agreement. Can they keep it? Okay, what is Nintendo's profit if it cheats, and what's Nintendo's profit if it cooperates? And then, most importantly, what's Nintendo going to do? Because what Nintendo does will dictate what both firms do, because it's a symmetrical matrix. Okay, remember, first you want to calculate the most likely number of times you want that, or they're going to play the game, which is just 1 divided by theta. So 1 divided by theta of 5%, so 1 divided by 0.05 is 20. So they're most likely going to play the game 20 times. So given that theta is 5%, you simply determine the most likely number of times they play the game is 20. And that's the agreement they're trying to keep. Okay, so if Nintendo cheats, cheating the first time, they get the 10 million. And then after they cheat, the agreement's over, and they go back to the Nash equilibrium, which gets 1 every time. So you play the game 10 times, so that means that they would cheat once, and get the 10 million. And then the other, they're going to play this game 20 times. So they cheat once and get the 10 million, 1 times 10, and then the other 19 times it's back to the Nash of 1. So they get one round of 10, and then 19 rounds of 1. So that accounts for the total 20, where you get 1 times 10, and then the other 19 you get 1. So it's 1 times 10 plus 19 times 1, and that gives us a projected profit of cheating for Nintendo of 19 million. Okay, but what about if they cooperate? So there's 2 ways to calculate this, and that's only because the payoff is the same every time. So you can do the profit of cooperating divided by theta, which is 5, divided by 5% of 0.05, or you know they're going to play the game. You know they're going to play the game most likely 20 times, and if they get 5 20 times, that'll be the expected profit. So either of these should be the same, 5 divided by 0.05, or 20 times 5, both give you 100 million for cooperating. So obviously the projected payout from cooperating is higher, so Nintendo's going to cooperate because the profit of cooperating 100 is bigger than the profit of cheating at 29, and the firms will stick to their agreement and price the game consoles at 200. So that's how you do the cooperating versus cheating. Okay, and then finally, we have a multi-stage game or a sequential game. Let's assume that Mario and Luigi face a multi-stage game where Mario is the leader and Luigi is the follower. Mario goes first and has to decide whether or not to marry Princess Peach. Mario has one decision to make: marry Princess Peach or don't marry Princess Peach. He goes first. If Mario marries Princess Peach, Luigi has two choices. The first option is for Luigi to be Mario's best man, in which case Mario earns 200 gold coins of happiness and Luigi earns 25. The second option is for Luigi to steal Mario's gold, where Mario earns 150 and Luigi earns 75. So that's the first part. And then if Mario doesn't marry Princess Peach, Luigi again has two options. The first option is for Luigi to sign up Mario for online dating, where Mario earns 100 and Luigi earns 25. And the second option is for Luigi to steal Mario's gold, where Mario earns 50 and Luigi earns 75. Alright, so there's a description. Now you just gotta draw the game tree and then define the subgame perfect Nash equilibrium, which is the equilibrium or the Nash for a sequential game. Okay, so Mario has two options: marry Princess Peach or don't marry Princess Peach. And then in response to those, Luigi goes second. Okay, so if Mario marries Princess Peach, Luigi can be Mario's best man, or he can steal Mario's gold. And then these are the outcomes. If Mario doesn't marry Princess Peach, Luigi has two different options: sign Mario up for online dating or steal Mario's gold, and then these are the payouts for those. Okay, so remember the way to solve this is to go to the second mover, the last mover, and figure out what they would do at that position first, and then go backwards. So if Luigi were here, the decision he would make would be he could be Mario's best man and get 25, or you could steal Mario's gold and get 75. So if Luigi gets to this point, he's going to steal Mario's gold. Now what about this option? Okay, Luigi can, at this decision, you can sign Mario up for online dating and get 25. Or you could steal Mario's gold and get 75. So either way, you can see that Luigi has essentially a dominant strategy. He's always going to steal Mario's gold because the payoff to him is better. So no matter what, Luigi is going to steal Mario's gold. Now Mario has to take that into consideration when he makes his first mover decision. So if Mario marries Princess Peach, Luigi steals the gold and Mario gets 150. If Mario doesn't marry Princess Peach, Luigi steals the gold and he gets 50. So Mario is comparing 150 with 50. Obviously, it's a much higher payout of gold coins to marry Princess Peach. So that's what he's going to do. So Mario's going to marry Princess Peach. Luigi's best response is to steal Mario's gold, and that is the solution here. So this is the outcome. Okay, and you can define the subgame perfect Nash equilibrium as such. List the strategies. So Mario's always going to marry Princess Peach, and Luigi's always going to steal Mario's gold. And the outcome is that Mario gets 150 gold coins, and Luigi gets 75 gold coins. Alright, so for the third and final question that we just did, there'll be one part on the one-time game. There'll be a game with an uncertain final period. And there'll be a multi-stage game where you draw the game tree and define the SPNE. and this is similar to what you did for chapter 10 homework. And I also put my Excel file for this one if you want to use that as an example. Okay, so under the practice exam plus solutions, the Excel file shows the game theory stuff. Okay, so there's the part A, B, C, and D with the payout matrix, and then part E and F is right there if you want to look at those as an example. And again, you can do the game theory part in Excel if you want to. You can use my example, or if it's easier for you, you can just draw the game on a separate piece of paper. Whatever way is better for you to get the answer sheet done. So you don't have to do it in Excel, but there's my example if you want to. Okay, so again, I think we've had a lot of practice on all of these questions, but any questions on the game theory stuff or any of these, or any of the practice questions? Okay, so this, the practice exam of solutions is posted already if you want to look at that. Let me post the actual final, and then we'll wrap things up, but give me a second here. Okay, so if you go to on Blackboard, the final exam summer 2020, I think I just posted the final, which is right here. Okay, and it tells you that same thing as the syllabus. So it's due by email Thursday, August 13th, which is this coming Thursday. So okay, and then question 1 is a bunch of questions on doing profit max and then identifying the market structure. Question 2 is on oligopoly and Carnot, You gonna do that analysis one more time? All right, and then question 3 is on game theory. So notice that this is usually it's the oligopoly market we do game theory, but you can also do it with monopolistic competition. And so everything's the same. I noticed that I did 2 shoe companies, Vans and Converse, and those are technically a monopolistic competition market because there's lots of shoe companies and lots of different sellers. So everything's the same. I did an example of shoe companies instead. And so those are technically monopolistic competition, but other than that, it's all the same. So just do the game theory analysis. You have a 1-10 game. You have the game with an insert and final period, and then you have the multi-stage game. And so you have the same type of problem there. The only difference is I chose shoe companies, which are technically monopolistic competition firms. Okay, so questions on what you have to do for the final? Thursday at midnight, sure, yeah. Okay, so, yeah, um, I'm teaching classes in the fall, but I don't know if I'm teaching any, at the moment I'm not teaching, any graduate business classes, only undergraduate. So sometimes usually I only teach, the graduate classes like the 525s and the 500s in the spring or the summer for whatever reason. So, yeah, so and I usually teach, I don't know if, I usually only teach 500B and 525, but sometimes I teach, so those are really only the only graduate classes I teach, all of them, from, at different times. So if you've taken this class, you probably don't need to, you've probably already taken, is 500B. And I don't know, finance 570 sometimes I teach that, but I don't know if that's relevant, but. Okay, let's see. So Okay, so just for today, make sure if you haven't submitted these already, you're going to turn in homework chapter 9 and homework chapter 10. Okay, so those go there. So most of you already done that, but the last two days need to get in today. And then for Thursday, like I said in the syllabus, you have those two blast assignments. Okay, so the oligopoly homework, the Excel and the oligopoly analysis just needs to go into the discussion forum there. So that goes there, and you just need to submit your Excel file or PDF. Only your Word document or PDF, no Excel file. And then the final exam is due via email, just like the midterm. And so you can email me your answer sheet by Thursday. And just the last few things, make sure you get these two homework in, most of you already have, and then make sure these have to be in by Thursday. And that way I can get your grades submitted, final grades submitted by the 15th on Saturday, like I promised. Okay, so you're welcome. So there shouldn't be any problems getting everything in by Thursday, right? Okay, yeah. All right, so I think that's all we got here for this course. And you got your last three assignments. If you have any questions on your oligopoly homework, doing Excel or anything else, you can let me know on that. If you have any midterm questions, final exam questions, you can email me on that. And those things are due by Thursday, and I'll get your grades in on Saturday. So if you have any more questions, let me know. If not, I think that's it. And thank you all for participating the whole summer. And I hope you enjoyed the course. And if you have any questions on the last couple of assignments, then you can let me know. So thank you. And I'll get today's video up today or tomorrow on YouTube.
Thank you.
Okay, thank you.